Hey guys, welcome back. We're just going to go through some of the special right triangles. You'll notice I've highlighted, well, not, I've boxed in blue below. These are the two special right triangles we're going to be talking about, the 30-60-90 and the 45-45-90. You'll notice that they have some expressions written around them. We'll be discussing those in more detail while we're in live stream. We're just going to look over a few problems. So the first problem is an escalator lifts people to the second floor of a building, 22 feet above the first floor. The escalator rises at a 30-degree angle to the nearest foot. How far does a person travel from the bottom to the top of the escalator? So you'll notice that we have a 30, 60, 90 here, right? Because this we can assume is 90. So we use the first case here with the little asterisks, the 30, 60, 90. And you'll notice that because of the way the patterns are set up, we knew what x was. X was equal to 22 feet. So if we just follow the pattern in the blue asterisks, it says take 2 times x, and that's the distance for the hypotenuse. So 2 times 22 is 44 feet. So the person travels 44 feet. All right, here's another 30, 60, 90. We're not really going to work on the 45, 45, 90 right now. You'll see why later, as we sort of already did. Okay, so we have another problem here, and it says a triangle is in the shape of a 30, 60, 90 right triangle. If the hypotenuse of the outer triangle is 21 feet, find the lengths of the legs of the triangle in inches. So what I did was I redrew the original problem over here. I'll put that in blue. And I put the expressions where they belong. Now, if I go back up here real quick, you'll notice that the smallest angle, 30 degrees, gives us the smallest side x. The biggest angle, 90, gives us the largest side, or the hypotenuse, 2x, and the opposite side to 60 gives us the space in between. It gives us the expression x, take whatever x is, and multiply it by the square root of 3. So that's what I did. I reminded you about what they were. And then I separated them into two cases, 1 and 2 over here. In the first one, I called it SL for shorter leg, and that equals x because it's opposite the 30 degrees. So that's quite easy to do. If we already know what x is, and we know what the expression is, then we know that the hypotenuse, 21, equals twice x. So solving for that, we just get 21 halves feet for x, which is indicated here that I'm boxing now in blue. Case 2 is the LL, or the longer leg, and that's set up with the expression of x square root of 3. So all I had to do was take the x and multiply it by the square root of 3, which is what I did here. Now, the problem says that we need to put them in what? Not feet, but inches, right? So what we did was we used dimensional analysis on the two cases, 1 and 2. And we started off with feet. Feet will cancel out with feet, leaving inches. Feet will cancel out with feet, leaving inches. I should have inches there. And when you do the calculations out, all I did was I said 12, this 12 right here, divided by 2 is 6, so 6 times 21 is 126 inches. And then since we knew what x is, I really didn't have to do the second case. All I had to do was take x, which was 126, and stick a square root of 3 next to it. That's the very simplistic way. We're going to go into much more detail during the live stream. So here's a problem. A farmer's conveyor belt carries bales of hay from the ground to the barn loft. The conveyor belt moves at 400 feet per minute. Complete parts A through D below. So part A says, which part of the right triangle does the conveyor belt represent? It's the hypotenuse. It's opposite. See, it's opposite the right angle. The hypotenuse is always opposite the right angle. Okay? B, how many minutes, or how are minutes and seconds related? 60 seconds equals 1 minute. I think that's okay, right? 1 minute equals 60 seconds. C, it says find the length of the conveyor belt. Well, I drew the regular triangle out, the 30, 60, 90. I labeled the shorter side that we had, which was X. So all I have to do to find the distance for the conveyor belt, right, is to take 2 times the value of the smaller side, which is X. So I took 2 times 17, came up with 34 feet. So the conveyor belt is 34 feet. D, how many seconds does it take for a bale of hay to go from the ground to the barn loft? Well, what do we know? We know that the belt moves at 400 feet per minute. But remember, the question wants us to know in seconds. So, since the belt has a length of 34 feet, we're just going to use dimensional analysis, dA here, and we're just going to set them up, right? So I'm going to start with what I know, which was the 34 feet. Feet will cancel out. Notice that I'm just using conversion factors to get to the units that I want. Minutes will cancel out, leaving just seconds. So all I did was, instead of using a calculator, I just did some cancellations. 60 divided by 400 is 6 over 40. So I just did that cancellation. Where did I get the 17 from? I divided the 34 by 2 and the 40 by 2. And that's how I got the 20 as well. And then I took the 6, I divided it by 2 and the 20 by 2. And that gave me a nice thing to work with, which was 51 tenths. So 51 over 10 seconds. Now you can do this all in the calculator, but like I said, it just takes a few seconds just to do this out by hand. So 51 divided by 10 is 5.1 seconds. So it takes 5.1 seconds. So I can just write it up here, 5.1 seconds. For a bale of hay to go from the ground to the barn loft. And hopefully that didn't go over time. I'm trying to keep it within the 5-minute spectrum. Let me know in the live stream if this helps. Thank you very much, and have a pleasant day. Bye.